The National Electrical Code, specifically Section 300.3b, addresses the practice of using certain types of metal raceways as a means of support for other equipment or wiring. This section is crucial for maintaining the integrity and safety of electrical installations. It clearly states that electrical metallic tubing, rigid metal conduit, intermediate metal conduit, liquid-tight flexible metal conduit, and metal cable tray shall not be used as a means of support for luminaires, fixtures, or other equipment. Firstly, let's break down each component of this code section. Electrical metallic tubing, often referred to as EMT, is a thin-walled metal raceway commonly used for protecting electrical conductors. Rigid metal conduit, or RMC, is a thicker, heavier-duty metal raceway designed for more demanding applications and environments. Intermediate metal conduit, or IMC, offers a middle ground between EMT and RMC in terms of thickness and strength. Liquid-tight flexible metal conduit, known as liquid-tight or flexible metal conduit, is a flexible metal raceway with a liquid-tight outer jacket suitable for wet or corrosive environments. Flexible metal conduit, or FMC, is a flexible metal raceway used for dry locations where flexibility is needed. Metal cable tray is a system of metal trays used to support insulated conductors and cable assemblies. Secondly, the prohibition against using these raceways as support structures is rooted in several key safety and performance considerations. One major concern is the potential for mechanical stress. When additional weight or tension is applied to a conduit system through the attachment of other equipment or wiring, it can compromise the structural integrity of the raceway. This can lead to several issues, including firstly, deformation or bending of the conduit, secondly, loosening of fittings and connections, and thirdly, damage to the conductors inside the raceway. Any of these scenarios can create a safety hazard, potentially resulting in electrical faults, arcing, or even physical injury. Another important factor is the intended function of the raceway. Conduit systems are primarily designed to protect electrical conductors from physical damage, moisture, and other environmental factors. They are not engineered to serve as structural supports for other equipment. Attaching additional loads to the conduit can exceed its design capacity, leading to premature failure. Furthermore, the practice of using conduit as support can interfere with the proper grounding and bonding of the electrical system. Grounding and bonding are critical for ensuring electrical safety by providing a low impedance path for fault currents to return to the source, thereby tripping circuit breakers or fuses and preventing electrical shock hazards. When additional equipment is attached to the conduit, it can disrupt the continuity of the grounding path, increasing the risk of electrical shock. In the scenario described, the electrical contractor's practice of attaching number 6 insulated green wires to the outside of the raceway using tie wraps violates NEC 300.3b. These green wires, which originate at different area ground buses and terminate at instrument junction boxes, are essentially being supported by the conduit system. This is not permitted under the code. It's important to note that the NEC does not allow any exceptions to this rule for the types of conduit listed in 300.3b. Regardless of the size, type, or installation method of the conduit, it cannot be used as a support for other equipment or wiring. To comply with the NEC, the electrical contractor should install a separate support system for the equipment bonding jumpers. This could involve using a dedicated cable tray, a separate conduit run, or other approved support methods. The key is to ensure that the bonding jumpers are properly supported without relying on the existing conduit system. When installing a separate support system, several factors should be considered. Firstly, the support system must be adequately sized to handle the weight and tension of the bonding jumpers. Secondly, the support system should be securely attached to the building structure or other suitable mounting points. Thirdly, the support system should be made of materials that are compatible with the environment and the type of wiring being supported. Fourthly, the installation must maintain proper grounding and bonding practices throughout the electrical system. It is also important to consider the accessibility of the bonding jumpers for future maintenance and inspection. The support system should be designed and installed in a way that allows easy access to the wiring without requiring the removal or disassembly of other equipment. In addition to complying with NEC 300.3b, it's also important to be aware of other relevant code sections that address the support and installation of electrical wiring. For example, NEC 314.23 covers the support of outlet boxes, device boxes, and conduit bodies. This section provides specific requirements for how these components must be supported to ensure their structural integrity. Similarly, NEC 392 addresses the installation of cable trays, including requirements for support spacing, grounding, and bonding. These sections provide detailed guidance on how to properly support electrical wiring and equipment in various applications. Furthermore, it is crucial to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and other applicable codes and standards. These professionals have the knowledge and experience necessary to design and install electrical systems that are safe, reliable, and compliant with all relevant regulations. In summary, NEC 300.3b prohibits the use of electrical metallic tubing, rigid metal conduit, intermediate metal conduit, liquid-tight flexible metal conduit, and metal cable tray as the means of support for luminaires, fixtures, or other equipment. This rule is intended to ensure the structural integrity of the raceway system, maintain proper grounding and bonding, and prevent safety hazards. To comply with the NEC, a separate support system must be installed for equipment bonding dampers and other wiring that cannot be supported by the conduit system. Always consult the latest edition of the NEC and other applicable codes and standards to ensure that all electrical work is performed in accordance with the regulations. Improper electrical installations can pose serious safety risks, including electrical shock, fire, and equipment damage. By following the NEC and employing qualified electricians, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. Remember that the National Electrical Code is a comprehensive set of guidelines designed to protect people and property from electrical hazards. Staying informed about the latest code requirements and best practices is essential for anyone involved in the design, installation, or maintenance of electrical systems. In the situation with the #6 green insulated wires tie wrapped to the outside of the raceway, there's another consideration that is related in terms of safety. While NEC 300.3b directly addresses the support issue, the manner in which the grounding conductors are attached raises additional concerns. Tie wraps, or cable ties, are generally not recognized as a suitable method for securing grounding or bonding conductors to a metallic raceway for several reasons. Firstly, the mechanical connection provided by a tie wrap may not be sufficiently robust to ensure a reliable electrical connection. Grounding and bonding conductors must be securely connected to a metal raceway to provide a low impedance path for fault currents. A loose or unreliable connection can increase the impedance of the grounding path, reducing its effectiveness in clearing faults and increasing the risk of electrical shock. Secondly, tie wraps are typically made of plastic or nylon, which are non-conductive materials. This means that they do not provide a direct electrical connection between the grounding conductor and the metal raceway. The grounding conductor must be in direct contact with the metal raceway to ensure proper bonding. Thirdly, over time, tie wraps can degrade due to exposure to ultraviolet radiation, temperature changes, and other environmental factors. This degradation can weaken the tie wrap, causing it to break or loosen, which can compromise the electrical connection. To ensure a proper and reliable grounding connection, grounding and bonding conductors should be attached to metal raceways using listed grounding fittings or other approved methods. These fittings are designed to provide a secure mechanical and electrical connection between the conductor and the raceway. They are typically made of metal and are designed to withstand the rigors of the environment. Some common types of grounding fittings include grounding bushings, grounding lock nuts, and grounding clamps. Grounding bushings are used to terminate grounding conductors to metal enclosures such as junction boxes or panel boards. They provide a smooth, rounded surface that protects the conductor from damage. Grounding lock nuts are used to secure metal conduit to metal enclosures. They have teeth that bite into the metal, providing a secure mechanical and electrical connection. Grounding clamps are used to attach grounding conductors to metal surfaces, such as pipes or equipment frames. They come in various sizes and styles to accommodate different types of conductors and surfaces. When selecting a grounding fitting, it's important to choose one that is listed for the specific application and that is compatible with the type of conductor and raceway being used. The fitting should be installed in accordance with the manufacturer's instructions and should be tightened to the proper torque to ensure a secure connection. In addition to using proper grounding fittings, it's also important to ensure that the metal raceway itself is properly grounded. This can be accomplished by bonding the raceway to the building's grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or other approved grounding electrodes. The raceway should be bonded to the grounding electrode system using a grounding electrode conductor. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the ungrounded service conductors. The grounding electrode conductor should be connected to the raceway using a listed grounding fitting or other approved method. In summary, the practice of attaching number 6 insulated green wires to the outside of the raceway using tie wraps is not only a violation of NEC 300.3b, but it also raises concerns about the reliability and effectiveness of the grounding system. To ensure a safe and compliant electrical installation, the electrical contractor should install a separate support system for the bonding jumpers and should use listed grounding fittings to properly connect the grounding conductors to the metal raceway. Always consult the latest edition of the NEC and other applicable codes and standards to ensure that all electrical work is performed in accordance with the regulations. And remember to consult with a qualified and licensed electrician.